Hello, morning. So those of you that are in Nova Scotia can see we are having a snow day, but because we're online, the university is closed, but we still have class. That's no fun. We should be able to get outdoors and play in the snow. Um, so there's a picture from last night when Dora was outdoors playing in the snow, but she goes crazy in it. But then when it gets as deep as it is out there now, um, her little legs are too short to run around in the snow. Anyway, but yeah, we didn't get a snow day. As soon as this class is over, I've got to get out shoveling. This was back in the fall, and it was a nicer day. And it's at Frog Pond. I recognized the ducks in the background, and it was cool, but it was a nice day. And someone sent me, and I forgot now who it was. We have a student that's in Corner Brook, Newfoundland at the moment, uh, and sent me a shot of Pinchgut Lake. I don't know Corner Brook at all. Never been up to that part of the province. My knowledge of Newfoundland is limited from childhood being on the south coast of Newfoundland where my grandparents lived. One of those remote outports that you got to only by boat, and they had no electricity, no nothing. It was um, interesting times back then. Great adventure for a child. Um, they And it's interesting how a number of the pictures that people send me are ones like the ones I take, which are ones that make me feel good. That and that's what pictures do to you. That pictures can challenge you, excite you, relax you, those sorts of things. They evoke emotions, and that was a point I was trying to get at last week when we were looking at charts. That looking at numbers tell us facts, but it doesn't. They don't necessarily evoke emotion, and charts are much better at that. And in communicating things, emotion can be far more powerful than fact. But let's get on with today. Now, yes, big disappointment, I think, to most on Friday. The average was only slightly better than 50%. That's nowhere near where I'd like it to be. So uh, the instructors, we've been emailing back and forth. We may have a meeting to go further on that to look at what exactly went wrong, were our expectations incorrect, and what sort of corrective action we should be looking at. Um, that It's disappointing because the last fall test, two students had trouble with it, and so put an awful lot of thought into uh, how the questions were crafted this time round and address some of the issues that we thought last time, which confused people. But obviously, that didn't work. In fact, I think you probably did worse than my classes did last fall. So, anyway, uh, we will get back to you by Wednesday as to what corrective action will be done on that. I've had a number contact me to indicate that uh, they had technical problems during the test, that it sort of shuts down the test partway through. Others that, for a variety of reasons, weren't able to write at all. Um, that Looking also at quiz for Chapter 5, there are a number of students didn't do it. I'm going to be following up with all of those people. Um, Maybe today. I've got to do a lot of shoveling ahead of me. If not, tomorrow morning. And what to do about those cases. I don't like people throwing away a whole bunch of points. That between the test and the quiz, someone that missed both, that's 10 points. That's a lot. So we've got to revisit that. So I will be in touch with you. That Assignment 2 has been posted. It's using the same data set we had from assignment one, but asking you to explore other sorts of things. With assignment one of the things we discovered was that you're studying a lot more than students did last year. And so, uh, curious to know, is that because you're more concerned about grades than last year's class, or you're more worried about that? That is it a different mix of students? Is it a demographic change that we've got? And with all that extra studying, is it really paying off? Are you actually doing better than because of all that? It turns out you are. You did incredibly well by the looks of things. The grades are reported to be very high. But even then, maybe it's a better class. Maybe it's you did better in high school. Uh, we're not going to look into those numeric patterns yet, but it is something that you may want to explore with. We'll be doing scatter charts today, and you could look at scatter charts to see what the pattern is between high school grades and grade point average, or number of hours that you spend studying and what your grade point average is. Uh, uh, some of the results are you may find disappointing or not be the patterns that you thought, but we'll be talking about those types of patterns today. Chapter 6, your quiz is due Saturday, and then after Saturday, you've got a break. Uh, and I've got a break to do some catch up. So next week is our break week. Skiers, looks like we're with the snow today, we're getting more on the weekend. So it's going to be good winter weather for those that like winter weather. I just don't like shoveling. Let's get on with the show today. Uh, Recap of last time. Uh, Box and whisker charts I introduced to you. It was something that we did manually, and one of the few things that we'll do manually. But I think it's useful to see where things come from. And that one, uh, having that tactile feel of doing it yourself, helps convey some of that type of thing. So we're looking for patterns and data. Generally, we're looking at comparisons. And so you've got all that data and all that information, a lot of that detail. Averages are great in trying to summarize things down and look at what are the key things and do that comparison. But in hiding the detail, maybe we're hiding something that's important, that we're just looking at average and we're not all average. We're above or below, we're different. And by hiding those differences, maybe that's something that's important that we're missing. But if you do it with histograms, you've got information overload. It's just too busy, and we can only really compare 2 or 3 groups at a time. Can't do a whole bunch at once. Does it start on Wednesday or next Monday? My understanding is break week is, it's Monday to Friday. That next Monday is Family Day or Heritage Day or something like that. It's a holiday. And so that's why they've built it's that whole week. Then we will not have any classes. So we won't have no class next Monday and Wednesday of next week. But we do have Wednesday this week. We have a class. That box and whisker charts try to highlight. Our week does start in terms of material. So that the chapter 6 will start on Wednesday. We will finish it not next Monday, but the week after. So there's a big sort of pause in between. But that's just in terms of the way I've got it structured. And I think the way I've got it posted, the week looks like the dates for beginning and end actually look like 2 weeks long. But it's just because there's a gap in the middle there. That box and whisker charts try to get our highlights down to 5 key points. So very low, low, medium, high, very high. But looking at 5 numbers is a lot. And if I was comparing 4 or 5 groups, I could be looking at 20, 25 numbers to look at, overwhelming. So that's why a chart ends up being nice. And being able to convey that in that visual fashion, we can absorb that quite quickly because we're looking at imagery and not looking at precise numbers. We're not looking at the detail. And the way we do it, and these are important things to think about. Why is it done the way it is? A lot of data analysis is a communication task, and communicating to an audience as to what you think is important in the data, and it's also communicating your own understanding is a way of how to make the data talk to you, communication. And so there's a lot of psychology here. Um, the books and articles don't talk about that, but it is important. The important part of a data set is it's the priority should be the middle 50%, worrying about where they are. And so that box draws your attention to here's the middle 50%. And I don't like the way Excel uses blue for everything because it makes it hard to see where the actual middle, the median is. So you may have to change some formatting there, but still that grabs you, that big box. But the bottom 25% and the top 25% are also very, very important groups. So what do they look like? How broadly are they scattered? And they're secondary. So whiskers, just even the difference between having a box versus having a whisker draws your attention in different ways. You definitely look at those whiskers. You aren't just focused on the box. And you're looking to see how long they are or how short they are. That they have less ink, so they're a little bit more peripheral to it, but they're still important. What is curious is how outliers draw your attention as well in these charts. They're well outside, and because they're so different, even if they're just a little dot, you definitely focus on them. Outliers are important, but they shouldn't be our focus. So an outlier, once you identify it, you make a note of it, you put it in your parking lot of issues to visit subsequently, and then you hide them. And so that is one nice feature in Excel, that it allows me to hide those outliers and focus on the important, the bulk of where my data is. And when I do that and I look across groups, the comparisons are really easy to do. And as I say, I feel the chart as opposed to reading it. And again, it's like these pictures, that seeing that, that picture in Corner Brook, which is very calming, that sunset and so on, it conveys a message to me. But many pictures are very restful. Others provoke other types of excitement. And pictures are very powerful in that regard. And they convey stuff more effectively than looking at numbers. So think about those things. It's not just a chart. If I want to move into, we've been looking at a lot of categorical stuff, and we're still going to briefly do that this class. But looking at patterns in numeric variables, that how do we get into that? We want to build a model, maybe to predict something, and we're going to move into that. By end of today, we're going to be seriously thinking about how do we start making predictions. But first, I want you to still focus on what are the relationships and what's important in that relationship, and exploring the data. So this is probably the last one where we're actively exploring. And so I'm going to use a data set that's associated with Chapter 5, and it's credit card data. And when you look at it, it's data on what appear to be 400 customers and their credit cards. Tells us what their income is, how many credit cards they have, what their credit rating is, what the limit is on their credit card, a variety of different sorts of things. And later, we're going to start getting into value estimation and making predictions. And we're going to use this data set to predict what their balance should be on the card. And like, I don't know, why would you want to do that? Okay. That's a model, but what was the question? Maybe the question you have is, I'm looking for unusual credit card activity or unusual credit card balances, ones that don't seem to fit the characteristics of a customer. So it may be someone that is running up their credit card balance because they figure they're in financial trouble. They're going to have to declare bankruptcy. And I'm going to take the money now before I get in trouble and I have bankruptcy. So these may be people that are likely to default. maybe it's some criminal activity, something like that. Or maybe you're finding customers that don't use their credit cards at all. And well, that's not good for you because you don't make money from them. So you'd like to change their behavior in some fashion. Um, Maybe you're trying to figure out their behavior, understanding why some people borrow and some don't. You like people to borrow because you make money off of that. That's what your business you're in with a credit card. And maybe you're trying to find out who borrows a lot and or who doesn't borrow a lot, so that you're trying to understand their how to if we could change their behavior, we could make more money. So there are a variety of things here that's the purpose of your model. That and it could be a causal modeling thing, it may be a classification thing, but maybe it starts out with trying to make predictions of how much they're going to borrow. And so let me just show you the data set. It looks like this. So I've got their income in thousands of dollars, what their credit limit is, their limit on their credit card, some rating score I've given them as to are they good customer or bad customer. Do I call them high risk or low risk? So if your credit score is low, you're high risk. If your credit score is high, then you're low risk. It's the other way around. How many credit cards do you have? Do you have a lot? That What's that tell me about you? What's your age like? Um, Maybe young customers and old customers are different. I need to know that. Education, I'm not sure what role that would play, but how many years of education you have. So instead of saying high school, college, university, saying how many years you've got. Um, 12 would be high school, and 16 would be probably a university degree or something like that. Is your gender male or female? Are you a student or not? Are you married or not? What's your ethnicity? And it says Asian, Caucasian, or African American. And what's the balance owing on your card? Now, back up a little bit. This isn't real data. It was created by a fellow, Gareth James, for a book he wrote on an introduction to statistical learning. It's uh, a fairly tough read of theory of data mining and that type of thing. And so we use this as for exercises within the book. I'm probably using it for different purposes than he had. I discovered it before I knew about his book, and it's simulated data. And you might, wonder like, if you've got a credit card, what's the limit on your card? $2,000, $5,000, $500? It's usually rounded off to a nice round figure. It isn't, $7,075 or $9,504. Why? So he randomly generated that, and same with education, picking these numbers. That and he's the University of California, Los Angeles, I think. Um, Ethnicity in the U.S. context, they tend to categorize only into these three categories. That so it's simulated data, but it's still fun for us to explore, and we can do some interesting stuff with it. That with it, I took his original data and I grouped people in terms of credit risk. And so I'd like to look at, instead of credit rating, just overall risk and see, is there a pattern between your riskiness and your balance owing? And so let me get back to my slides here. So does the credit card balance vary among those three groups? So let's see what we can find out. I could do that with what I used last class. I could do a box and whisker chart. And so I could have my high risk, medium risk, low risk, and see how do they compare one to the other. And that you'll see with the high risk, they don't borrow very much. Maybe they're trying to improve their credit rating. And so if they borrow money, they pay it off right away. So they try to carry a balance around zero. But there are a few that do borrow more, like someone with a better risk score. People with very, very low risk, they are quite comfortable carrying a balance. They're probably low risk because they pay it off all the time. And so they seem to be able to manage it. Okay, all right. But do I need to categorize them like this? Couldn't I just look at their credit rating on the horizontal and the balance on the vertical? And you can, and you get a scatter chart. And so over here you can see a scatter chart of that. So before I explore those two, any thoughts as to which one you like better? Would you prefer a scatter chart to show the pattern, or would you prefer this box and whisker chart to show the pattern? Try typing in your comment. There's no right answer to this. I'm just interested in your views as to which you like better and maybe why you like it better. Yeah, many people like scatter charts. Um, and uh, some don't like box and whisker because it's foreign to them. Scatter chart seems more natural, something that they're used to seeing. Box and whisker, though, turns out to be useful in some applications. If I had not 400 observations here, but 40,000, so I had a lot of data. And if I was a bank, I would have lots of data. I would have hundreds of thousands of credit card holders. Any thoughts on what the scatter chart would look like if I had 40,000 dots in that picture? What do you mean by very busy? You know, busy is a term I keep using. Solid blue. It isn't just clustered, it is solid. That look at these ones here, these overlapping ones, that it's filling things in. And so if I keep adding more points in, I'll keep filling in missing white spaces. And all the white space in here would disappear, but it would actually disappear out here as well. So I'd have not just more in the middle, but I'd have more at the extremes. I might end up, I don't know if you can see my cursor here going around, I could just have a great big blue blob. And I might not even actually see the pattern that's here, that it seems to be upward sloping like this because there's just so much blue in there. Whereas in the box and whisker chart, if you ignore outliers, the chart would look the same. It would not change much. It's still middle 50%, top 25, bottom 25. The only thing that would happen would be I'd get more outliers if I had 40,000. So this chart stays the same regardless of how much data I've got. So it's sometimes attractive. But if that was the only reason for using the box and whisker, I might say, well, do I really need 40,000 dots in this? I could either make my dots much, much, much smaller to spread them out, or why wouldn't I just take 400 of them or 500 or some smaller number so I wouldn't get overwhelmed with ink? So there are ways around it, but there are different approaches. So with the scatter charts, um, how do I do that in Excel? And you may have done them before. They're not hard to do. I could just go grab rating. I go over here, I grab balance. I could go up here to insert. I could hit recommended charts. And it says pick a scatter chart. I click OK, and there it is. So it's relatively quick and easy to do to be able to get this type of chart. That sometimes with charts in Excel, it varies. But sometimes with charts, when you pick the label, and I picked the label with these ones, I grabbed everything in the rating column, everything in the balance column, including the labels at the top. Sometimes it doesn't recognize that I've grabbed labels and not just numbers, and that it does bizarre things to me and messes up my chart altogether. So sometimes you may find if you get garbage, go back and redo it and just select the numbers and don't select the labels. And But Excel, it can sometimes be unpredictable. That when you're creating a chart, try to get in the habit of giving it good titles, good labels. So this one I might say um, uh, goes with um, uh, good ratings for more. There we go. Your picture is telling a story. You're trying to convey some image here. So tell the reader right at the top what it is you're trying to tell them. Don't make them work harder. And they'll see that title and they'll look below and say, oh, yeah, those with a higher rating seem to borrow more. It's obvious, but state the obvious. Some people don't see the obvious. The other, though, is label your axes. Um, I didn't teach quant one this year, but um, I know when I've taught it before, we would often have you do charts and that sort of thing. And one of the most frequent problems, students didn't label their axes. They might put X and Y, but what's X and what's Y? So here, I should be putting in credit rating. I know that's what's on the horizontal. And that on my vertical, I want to put in um, my card balance. I, I don't like vertical things. This is the norm because it takes up less space. But if you're like me and don't like this, or your audience you think will not want to turn their head to read, you can click on it, right click, Format Axis Title comes up if you've clicked properly. Gives you different things. I think if you click this one, you may not be able to read this, but it says text direction. And I can rotate the text to make it horizontal. There, that's easier to read. If you want to take up a little bit less space, you could do it that way and split it over 2 lines. Get this out of my way. And here's a better chart. Okay. So these things are really nice, quick, easy to do. And they tell me, is there a pattern here or not? That I should warn you though, when doing these in Excel, that it put rating on the horizontal axis and it put credit card balance on the vertical axis. How did it know to do that? Why didn't it put balance on the horizontal and rating on the vertical? Well, I'll show you a chart where it does that. Let's look at income and age. And I might want to know, as you get older, does your income go up? Should be, I would think, that you're generally older people earn more than younger people. So let's go and insert a chart there. Insert chart. Going to do a scatter chart. Good. Great. And what's my chart look like here? Me. That other one's hiding in the background there. So you can see my chart here. And whoa, look at it. These are supposed to be ages on the horizontal and income on the vertical in thousands of dollars. And what am I getting here? I've got people that are 10 years old up to 185 years old, and incomes anywhere from 20,000 to 80, maybe 100,000. Something's wrong. My clue might be the label that's up here. It says age. If it's grabbed labels, it usually puts the label of the vertical axis. I've got it backwards. These are ages, and what's on the horizontal are incomes. Fine, I'll flip it around. I see up here there's switch row and column. Seems like a good. Can't do that. My issue isn't rows and columns. My data is in columns. I have a column of income and a column of ages. my data isn't in rows. So it isn't a row column thing. It's, I've got them in the wrong order. How do I switch the order? Well, it doesn't work easily. What I've got to do is I want age to be first. Okay. That, I'm going to put it in a new sheet. And I want income. I'm going to put that item. The only difference from my previous sheet is the previous sheet had income on the left and age on the right. Now I've got age on the left, income on the right. And if I grab these two, I go up to insert. I go and put in my chart. Click OK, get my chart. And it's putting income on the vertical axis. You look, if you can see these numbers, it goes from about age of about 22, 23 years old up to someone that must be about 98. And income is going from about $10,000 up to about $180,000. Now it's the right way around. Not much of a pattern there, I must say, but the to get them the right way around, what you want on your x-axis has to be the first column, and on your y-axis has to be the second column. Okay? So let me go back to what I had before here and go back to my slides. So I just did it, made it up. Those were the instructions I followed. And I added different chart elements to it. So I could go and do this with a whole bunch of others. Now my data set's nice because balance is on the far right. So generating all the other charts was relatively quick and easy to do because the other variables like income, credit limit, age are all to the left of balance. You just see what I mean here. Balance is on the far right, and so it was on the vertical axis. So all the other variables to the left. So it made it easy for me to generate all the different charts. And do I have it here? Oh, here are all my charts for today. So you can see them all here. So there's a variety of patterns here. I make that just a tiny bit bigger. That if you look at them, this is the first one we had with rating. It's a nice upward sloping pattern. Income, people that have a higher income, they do tend to borrow a bit more, but it's pretty broad scatter that I've got here. If I look at the limit on your credit card, if you have a higher limit, you borrow more, but it is not because you're getting maxed out. Here, this is a limit of $14,000, and that person is only carrying a balance of 2,000. So, yes, people that have lower limits still seem to borrow more. Here's a limit of $2,000. The lowest ones are, maybe down around 500, but even with a limit of $2,000, people are borrowing, carrying a balance of almost nothing. So that looking at some of the others, as you have more credit cards, doesn't seem to tell me anything. As you get older, it tells me absolutely nothing. There's no pattern here whatsoever, perfectly flat. And with education, again, doesn't seem to tell me anything. And I must say, this was funny data. I thought when I first, there are all these people that only have grade 5, grade 6, grade 7 education. No, it's that fake data that he just made up those numbers. But anyway, there's some interesting patterns here. Which ones should we pay attention to? Which ones shouldn't we? We'd probably want to pay attention to these top three and not to the bottom three. That the top three have a strong pattern, the bottom three, there's probably nothing there. And so I'm saying a strong pattern, a weak pattern. Can you actually come up with an indicator to say what is strong and what is weak? And we do. That. So I'm going to walk you through how to find it or how it's calculated. So here's the one with credit limit. And the method we're going to use goes back probably 100 years or more, probably more than that. I think Carl Pearson is the guy given credit for it, but there were probably others involved. That if we looked at whether or not you're above or below average with respect to your credit limit and with your card balance. So the average credit rating was, or this is credit limit data here. The average credit limit was 5,000 and the average balance was about 500. So if someone had a low credit limit, they also seem to have a low card balance. A lot of data that's clustered here. There are some, though, that have a low limit but borrowed more. On the other hand, data is very skewed. There's a lot on the bottom end and not as much on the top end, spread out in the top end. That those that had above average credit limits, they generally borrowed more. There's a lot up in this quadrant. And there's much less in these other two quadrants. So I've used minuses and pluses. Below average on credit limit, plus meaning above average on balance. Here's plus plus, so it's above average on limit and it's above average on balance. So we've got this sort of balance, this mix that we've got. If you looked at age data, and I did the split, it's pretty balanced in terms of, above, below, left, right. And so it doesn't have that same strong pattern that we had previously. So if there's a strong pattern, they're clustered in certain quadrants. And if there's no pattern, they're spread out across all the quadrants. So these are, I'm talking about being spread out. It means it's the diversity, the variability in the data. And we looked at variability before when we looked at variance, standard deviation, odd numbers to look at, but they were measured in terms of variability about how far you are from the middle. Are you close to the middle? Are you far from the middle? Do we have a lot of values that are close to the middle? Do we have a lot of values that are far from the middle? And we looked at, on average, how far are you from the middle in a squared sense? So what happens if I look at how far you are from the middle in terms of these quadrants? Well, and if I multiplied things together, so if you were in the bottom left quadrant, you're below average, below average. If I multiply a negative times a negative, I get a positive. If I multiply a positive times a positive, I get a positive. So these ones, when I measure how far you are left, right versus up, down, if you're down here, I get a positive when I multiply those two together. And if you're up here, I get a positive if you multiply them together. But if you're over here or over here, I get negatives. And so I got some positive products and negative products. Well, and so if I'm clustered in this quadrant, I got positive, and in this quadrant, positive. And if I'm not in these ones, then they're not going to be as much. If I've got a strong pattern, the positives dominate the negatives. If I've got no pattern, the negatives and the positives balance each other. So they came up with this idea of if variance is deviations from the mean squared, covariance is how they co-vary, how they move together, left to right versus up and down, and look at those products. And that we're also looking at the pattern, and these are ones that your eye gets drawn to. Not so much these ones that are in the middle, it's these ones up here. If I cut this off and you couldn't see the stuff up there, and I've I cut this off so you couldn't see the bottom down there, you wouldn't be drawn to that pattern. It's these ones that are out at the ends that have so much pull, and they make these products really, really big because this is a big deviation to the right and a big deviation upwards. So when I multiply those two together, I get a super big number. Whereas these ones, when I look at the deviations of up, down versus left, right, they're both small numbers. I multiply them together, and I still get a small number. So covariance, I'll get a big positive total if it's upward sloping. If it was downward sloping, most of my data is in a negative and in a negative, so I'm going to get a negative total for downward sloping. Hard to understand though, what's a big number, a small number? They actually depend upon the units you're using. So if you scale it so that we don't have to worry about units, we could divide by standard deviations by how spread out it is left to right, spread out up and down. And what you get is correlation coefficient. We just call it correlation. Its proper name is Pearson's product moment coefficient of linear correlation. Quite a mouthful. Everyone just calls it correlation. There are other measures of correlation, but this is the one. If someone is saying that these two variables are correlated, they're probably thinking in terms of this measure that's being used. So it's a number. It's going to go from -1 to +1. Okay. Now, all noisy. So it'll have a correlation around 0. Okay. If I've got a strong band that's going up, I should have a correlation that gets closer to a 1. And if it's a strong band going down, I should get a value that's very close to -1. So, and if I was to show you, let me just show you a picture of my data here again. Two, that credit limit and credit rating. Okay, they're not ones we're looking at, but if I looked at a chart of them, this is what I mean by something that looks like a straight line that's pretty tight. And we'll see what its correlation is in a minute. But this is one that should be very, very close to a +1. So if this was something very, very, very close to a +1, what would you think the correlation is for something like this? Or something like that? This looks like 0. There's nothing happening. That's probably close to 0. There's nothing happening here. But this one here, there's a bit of a pattern. Any thoughts what you think the correlation might be for this pattern versus that pattern? It's going to be positive. Oh, I thought Abigail was typing something. Anyone want to take a guess? You think this is like 0.1, 0.5, 0.8? Pick a number. 0.4? Actually, you're pretty close. I, when looking at it, thought, oh, I can barely see the pattern. I'd think this was 0.1 or 0.2. This one over here, strong pattern, but still a lot of scatter. I might say maybe 0.7, 0.6, 0.7. Okay, let's go and take a look and see what we got here. If you've read ahead, you would know because I've used this, I think, in the. This one is 0.86. I was surprised how high that was. This is 0.46. I couldn't believe how high that was. Well, I should know. I'm used to this. Many people, if they said the correlation was 0.46, they'd say, okay, well, it's not perfect, but it's probably pretty good. And when I look at the scatter, I'd say, really? That's good? I don't think so. Looks pretty weak to me. These ones here are really noisy, so I'm not surprised they're around 0. 0.86, that's so close to 1. That's like getting an 86 on a test, you'd think, because the highest is 100%. Yeah, that's a solid A. Okay. Looks pretty noisy to me. it's not as high as I would have thought. I think it's valuable for you to associate pictures with numbers so that when you see a number, you know how to feel it. So when you're told that outdoors it's -4 right now, well, it's -4. Well, get out there and you'll feel it and you'll know what -4 feels like. If you're an international student and you came here from Bahamas uh, and you were told it's cold at -4, okay, what's -4? If you've never felt it, you probably would have trouble picturing it and picturing what's the difference between -4 and +4, um, or even +10. You know, what is cold? Uh, if you felt it, you'll know what it is. Okay, that uh, these numbers are very abstract. That um, uh, if you've grown up in a Celsius world and you watch U.S. television and you see a local weather report and they're saying the high today is 28. Oh, great! No, 28's cold because they're using a Fahrenheit system. Understanding a number, you have to have some sense of what it feels like. And so I think it's very valuable for you to start trying to associate pictures with numbers. Just it helps guide you. So this would be something close to a minus zero point 0.9, probably minus 0.94. It's fairly sharply going down. Okay? Very close to -1. What about these two? Any thoughts? Anyone want to type something? Yep, Dominic. It's low. It's so low it's probably close to zero in both cases, yeah, because the correlation is based upon a straight line. Okay, it's splitting things into 4 quadrants. And so if you split this vertically and horizontally into 4 quadrants, you're going to find a cluster in the top quadrant, cluster here, and cluster there. And they all balance one another out. That when I'm measuring correlation, it's linear. It's putting a straight line. The best straight line through that data is a horizontal one. And same with this one. It may be slightly downward sloping, but it's almost a horizontal line. So if you're you measure the correlation and it comes back close to zero, it may not mean that there's no relationship. It's just there's no straight line relationship. Okay? It's a linear relationship. That, but these numbers are quick and easy. If I'm sifting through a whole bunch of variables quickly, looking at correlation coefficients, I can scan them quickly and see which are the ones that are really important, and which ones are the ones that aren't important. That, but I've got to remember I'm only looking for straight lines. So it may be something that's important, but not as a straight line. Uh, the other is to be cautious about outliers. I know it doesn't show with this. This one here, these ones here have a big influence on that correlation coefficient, as do the ones down here. One of my first experiences in doing real data analysis, I thought I had an amazingly high correlation. It was a data set, the correlation was 0.99 something. It was crazy. And I went back to one of my old professors, pretty grouchy guy that I didn't like, but he would at least tell me what's wrong. And it turned out that what I had was a data set that if I had plotted it, which I hadn't, this was before we had tools like this readily available. Yeah, those days when computers were as big as my house, that it turned out it was like having a data set like this, but with all of these ones down here in the bottom corner, this was all empty. There was nothing there. And then I had a cluster way up here. And so, yeah, there was almost a perfect straight line between a blob here and a little blob up here. I didn't necessarily have a strong correlation. What I had were two groups that were very different from each other. And I was comparing two groups. If I looked at where did these ones come from, where did these ones come from, I understood, oh, They're apples and oranges, and they're very, very different in terms of the variables that I was measuring. And it was differences between two groups, not necessarily between two variables. So be cautious in some of it. So if you get a correlation that's close to +1 or close to -1, it's probably too good to be true. Look into it. It's probably not true. Now, if I try to do this in Excel, I can, if I take my data sheet here, let me just move this. Can I throw it down below somewhere? Out of my way. If I wanted the correlation between rating and balance, and I went to data analysis, there's a function called correlation. It asks me, where is my data? And I'll tell it, excuse me, where is my data? Well, it's in column D, back up here, column D, and it's in column M. And I click OK. I get an error message. It says input range must be a contiguous reference. What does contiguous mean? Big word. It means they have to be beside each other. There cannot be gaps between it. So rating has to be beside balance. So I could copy those into a new sheet. And then if I wanted to go and look at income and limit and age and credit cards and education, copy them all over. Well, let me just cancel here. Cancel again. I did that already. Don't look at the answer here. That was from this morning for you. So I put all of the number variables together here. Now I still don't have rating right beside balance, but I'm going to be lazy. I'm going to go to data analysis, correlation. It asks me, where is my data? Well, my data is in column B all the way across to column H. It's in columns. I've got labels in the first row. Watch it, make sure you do that. I'm going to put it right here in J1. I'm going to paste it in so you can see it beside the data. Chuck, 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 chuck. Takes a second. It does all the correlations for me. If I was looking at every pair of variables, so even the ones that aren't side by side, it took all the pairs. So for balance, correlation with income is 0.46, with limit 0.86, with rating also 0.86, with number of cards that's 0.086. Remember, cards, age, education, no patterns. Correlations are all very close to zero. But I can also look at, remember that picture I had of limit and rating? Correlation is 0.99688. It's as close to 1 as you could possibly get. So that's almost a perfect straight line. If you were looking at rating and income, well, those with a higher income seem to have a higher credit rating. Correlation is 0.79. So there's a strong pattern between income and rating. On the diagonal, everything is a 1. That's because income with itself is 1. It's perfect. If I know your income, I know your income. They move together. And I don't need all this space up here, this blank space. This is limit and education. Oh, well, I could go and look at limit and education. It's going to be the same as this number. It's just reversed. Correlation doesn't matter which order you've got it. X then Y or Y then X. The correlation is still measured the same way. So this table gives me a quick insight as to which of my variables are related to each other and which ones don't seem to be related to each other. It's really powerful, useful sort of thing. Okay. Something probably I didn't mention in the text, but I should draw your attention to. Scroll down through here. Anybody notice anything particular about this data set? I know there's just numbers, numbers, number. Anything odd or not odd? Anything compared to the No blanks. Abigail, you've got it. The data sets you've been working with, the survey data for assignment 1, the one you'll use for assignment 2, has got blanks in it. If I was to go and do the calculations to find correlation, I have to take a value minus the average multiplied by a value minus an average. What do I do if there's a blank? I can't calculate it. I can't calculate correlations if they're blanks. So if I had a blank in here, I'd have to go and remove that one altogether because it's just, I'll get an error message if there are blanks in it. So I suggest with the data set you've got for assignment 2, why don't you look at the relationship between high school average and grade point average? You can do a scatter plot and you can see the pattern that's there. But to find the correlation, you're going to have to remove all those records that have blanks in them. It's a tedious process. I did it. I had to remove about 20% of the data because there are blanks in the high school average or grade point average, or how many hours you spent studying, or how many hours you spent doing other things. And so unfortunately, I had to throw away a lot of data to be able to find correlations. I won't give away any secrets as to what those correlations were. You'll probably be able to spot what they probably would have been with the scatter chart. With a scatter chart, and if something is blank, it just doesn't show it because it doesn't have a point, a dot to put on the picture. Um, so that's not a problem with it. But with a lot of the material from here on in the course, blanks are going to be a problem because blanks I can't put into a formula. I don't know how to calculate things when I don't have something to calculate with. So it is an issue. It's beyond the scope of the course as to what to do with the missing values. There are some patches people use, but generally it's still a problem. When I threw out 20%, maybe that 20% of the data is the most interesting 20% of the data, and now it's not going to be representative of the students in the course, be able to look for patterns. So um, that was how I did everything, and I interpreted them. So I'm going to stop here for today. Because next class, we're going to get into modeling. We're going to go back and look at classic data mining applications. In particular, we're going to be looking at value estimation to get started with. And we're going to be looking at how we take, in this case, customer characteristics and start building a model of to predict what their credit card balance would be. And we'll spend a couple classes looking at that. And what's the process we should follow in building a model? It doesn't just happen. And there's no one strategy for building a model. There are lots of different approaches we could take. But we'll do it incrementally as we do, and using much of what we've done here. So if I was going to build a model, and you already have a clue that because I'm looking at linear correlation, I'm going to be looking at straight line models and some variations on that, what we do if it isn't a straight line. So if I was to start out with as simple a model as possible, and we like to generally keep things simple as possible, and I was going to predict balance, and I'm going to use one customer characteristic, then I might be inclined to say, okay, I'll take credit rating because that seems to be the best variable to use. But then I'll have to go back and ask, well, which one should I add to that? And then what other ones would I add to that model? If you look back at our picture, we're going to do a couple of things. Let me see. That's not the one I want. Let me, yeah, let me, yeah, get rid of, whoops. Just want to get rid of a chart here. No, not that one. Here, there. Let me look at this chart here. So with this chart, we're going to look at linear models. So just to give you an idea where we're going. And I'm going to put a straight line through my data here. And I got to try to figure out what's the best straight line to put through it. And I'll start out by, I'm going to use a tool in Excel, whoops, give me a best line. This is what it, get this out of my way, clutter. This is what Excel is telling me is the best line. It says if I want to put a line through this scatter of points, I should use this orange line. Why? Couldn't I pick a different line? Maybe I want to use a line that goes more like, it's a little bit lower down over like this. So here's my line. Mine's red and it's even fatter. There. I like this one. Or no, let move it up a little bit. Maybe it should be like this. Or maybe it should be a little bit steeper, like that. So it's not that different from the other one, but I'd like to wiggle it around. How do I decide what's a good line to put through it? Because I got lots of choices. And they're all straight. And so we got to look at how do you do that? And then I got to look at, is it a very good one? And you might notice this scatter seems to actually be sort of twisty. It's a curve. Well, but I can't deal with curves. I got straight lines. Well, there may be ways around that. I've also got other information. Maybe I should add in additional variables. And how should I add them in? And there are different strategies. We're going to be using a relatively simple approach for doing it that at least makes sense. It's logical as you work through it. It would be like building a team. So if you were a bunch of friends getting together, you're going to play a pickup game of hockey, and you're going to both have your own teams, and you are supposed to pick your team, and you each take turns. I pick one, other guy picks one, go back and forth, back and forth. I might start out saying, okay, I want a really good goalie, first of all. And so I pick a great goalie so that the other team can't score on me very well. And then, oh, it's my turn again. I'm going to pick another player. Well, maybe the next best player for me to pick is also a goalie. I said, yeah, but I don't need another goalie. I've already got one. I want someone that can score really well. So my second choice depends upon the choices I've already made. It's incremental. So what's the next best one to add given the ones I've already got? And we'll use that type of strategy. Say, well, what are you missing on your team? What ways can you improve your team? And we'll add in the one that seems to help be that best addition to the team. And that's the strategy we'll be using in a different sort of fashion. Anyway, that's where we're going to end it today. So we've got one class Wednesday. We're going to start in on chapter 6 and get a little bit into this, but the main meat of it is going to come after the break. And so we'll pick things up at that time. And on Wednesday, I should be able to give you a little bit more feedback about what's happening with how we're going to deal with the poor results on the test. And a bunch of you may be hearing from me because you didn't write the test. Anyway, take care and be back in touch on Wednesday. Bye now.